This video, we will talk about the empirical rule. In a normal distribution, approximately 68% of your data will be within one standard deviation of the mean. Approximately 95% of your data will be within two standard deviations of the mean. And approximately 99.7% of the data will be within three standard deviations of the mean. So don't forget, when you go to our symbolism, Greek letter mu is our mean. Sigma, this is lowercase sigma, is standard deviation. So our mean is in the middle. In the normal distribution, this bell-shaped curve is symmetric about the mean. That means 50% of your data will be to the right of your mean, and 50% of your data will be to the left of your mean. In other words, 50% of your data will be greater than your mean, 50% of your data will be less than your mean. And it reflects about your mean. That means whatever goes on the right side of it goes on the left side of it as well. So your mean is in the middle. It says within one standard deviation of your mean is 68% of your data. So in other words, if I were to add a standard deviation and subtract a standard deviation, I would have 68% of my data. That's why you have 34% on this side, 34% on this side. Then if I were to add two standard deviations and subtract two standard deviations from the mean, I would have 95% of my data. 13.5, 34, 34, and 13.5. If I were to add them together, it would give me 95%. So 95% of my data would be within two standard deviations of my mean. Then if I were to add another standard deviation, in other words, add three standard deviations and subtract three standard deviations from my mean, I would have 99.7% of my data. And then notice on the tails, we have 0.15 and 0.15. Let's add those together as 0.3. Add the 0.3 to the 99.7, that gives us 100% of our data. So these percentages will not change according to your empirical rule. The numbers down bottom will, according to what your mean is and your standard deviation would be, but the percentages will not change. So let's look at putting some numbers on this. So our example, a survey of 1,000 US gas stations found that the price charged for a gallon of regular gas could be closely approximated by a normal distribution, that's the bell-shaped curve, with the mean of $3.10 and standard deviation of 18 cents. How many gas stations charge between $2.74 and $3.46? How many charge less than $3.28? How many charge more than $3.46? So first thing we want to do is find the right side of the normal distribution. Don't forget our mean, they told us, is $3.10. Standard deviation is 18 cents. So to find the first step, I will add a standard deviation to the $3.10. So it's $3.10 plus 18 cents, that's $3.28. Add another standard deviation. So if you want to do 2 times 18 cents, that's fine. We'll just add 18 cents to this $3.28. But add another standard deviation, that'll be $3.46. Then add one more standard deviation, that's $3.64. So all you did was add a standard deviation, which is 18 cents, 3 different times to $3.10. 18 cents plus 310 is 28, 328. Add 18 is 346. Add another 18 is 364. Then the left side of your normal distribution, we're going to subtract 0.18 from the 310. Subtract 18.18 one time, you get $2.92. Subtract 18 cents another time, that's $2.74. Subtract 18 cents one more time, that's $2.56. If you're using the empirical rule, this is the process that you use each time. You're going to take your mean, whatever your mean is, add the standard deviation to it 3 different times. Then take your mean and subtract the standard deviation from it 3 different times. Then we'll be able to fill out the empirical rule chart in which 310, our mean is in the middle. And then here, this is our adding the standard deviation 3 different times. And then on the left side of it, it's subtracting the standard deviation 3 different times. Once again, the percentages stay the same. Now we can answer the questions. A says how many of the gas stations were charging between $2.74 and $3.46. So notice we have $2.74 here, $3.46 here. All we have to do is add up the percentages that are in between those two values, because you want to know how much or what percentage of gas stations are in between. So we took the 13.5, the 34, the 34, the 13.5, and that will give us 95% of our data, which is what we should have known from the empirical rule. Within 2 standard deviations of our mean is 95% of our data. Then you take that 95%, convert it to a decimal, and multiply it times how many gas stations we had in total. So that's 95.95 times 1,000. So if I want to know what is 95% of 1,000, because I have 1,000 gas stations, what is 95% of 1,000 gas stations? It would be the 0.95 times 1,000, which was 950. All right. Next, we want to know how many charge less than $3.28. Go to the $3.28, which is right here. Add up all of these data values, all these percentages, excuse me. So there's the 0.15, the 2.35, 13.5, 34, and 34. That gives us 84% of the gas stations will charge less than $3.28. So once again, take that 84%, multiply it times 1,000 gas stations that we had. Before you multiply, convert it to that decimal. It's 0.84 times 1,000. That's 840 gas stations will charge less than this $3.28. Last one, C. Count says how many would charge more than $3.46. So you go to 346, which is right here. Use the percentages that are more than. That's to the right. Less than is to the left of it. More than is to the right of it. So to the right is 235 and the 0.15. So we add those two together. It's 2.5% of the gas stations will charge more than $3.46. So we take that 2.5%, convert it to the decimal. That's moving the decimal two places to the left. That's 0.025 times it times 1,000, which is the total number of gas stations that we had, and that'll be 25. So we expect 25 gas stations to charge less than the 1,000. Oh, excuse me, 25 gas stations will charge more than the 346. All right, so let me know if you have any questions, and we'll go from there.